So in the previous video, if you haven't watched the previous video, please do check it out. We went about on how to solve question A of this particular question. So what we're going to be doing in this video is we're just going to try and expand more and try and solve part B of this particular question. So part B reads that if we have the displacement of the base that is given as that much, right, given by that particular equation, we are asked to derive the equation of motion for the particular solution, right? And they go on to say and explain in words how you'd solve it. Okay, so we are just going to derive the equation of motion for that particular solution, and we're not going to solve it, but we're just going to explain in words how we would have gone about to solve that particular equation that we have, that particular solution that we would have derived. Okay, so let's start. So what do we know about this problem? Well, part B, what we do know is that one critical thing to understand is that what sort of motion is happening here. So we have established that it's a single degree of freedom, right? Right? So we have identified that it's a single degree of freedom excitation, right? But we also saw, or we can also see that this is the displacement of the base is the source of this vibration or source of excitation that is causing this vibration, right? So the single degree of freedom, and in this particular case, the source of the excitation is base excitation, right? So the foundation is the reception of the earthquake, and which is then now transmitted to the building, where the building, as we saw in part A of the question, the building was also going to vibrate, whereby it was going to vibrate with a certain maximum amplitude. Please check out the previous video for part A for more clarity on that. Okay, so what do we know about base excitation? Well, we do know that the general differential equation for that particular case is given for a base excitation is given by mx double dot multiplied by kx minus y, right, plus the damping, right, which is the damping x dot minus y dot is equal to 0. Okay, so what is x, what is y? So remember, y is the displacement. If I can take you through some theory, you're going to see that y is the displacement of the base, right? So y is the displacement of the base, and x is the displacement of the system M. Okay, so going back to that, what you will then see is that we are now just going to quickly clean up this equation, and how we're going to do that is we're going to rewrite it in such a way that the k and the like terms are grouped together. Okay, so we have mx double dot plus kx, right, plus we also have cx dot is equal to ky plus cy dot. Okay, so now what we are going to do from here is we are now going to remember what we do with normally with these differential equations is we assume a solution, right? So there is an assumed solution that is available for the different case, like just what we did for the harmonic excitations. We had an assumed solution for the on how we can go about to solve that particular differential equation. The same for free vibration. We had assumed solutions for the different free vibration, be it free damped, free undamped. We had assumed solutions for that. And for harmonic excitation, we initially, if not given, we assume a solution of y is equal to sine omega t, right? But in this particular question, we are given that the solution is yt is equal to a sine 60t minus b sine 30t millimeters. Okay, so we are given this equation. We are given this solution. So what does that mean? Well, what it simply means is wherever there is a y, we are going to substitute with this particular value. And wherever there is a y dot, we're going to substitute the derivative of yt. Okay, so if we do that, so if I can just rewrite it again here, if we do that, plus kx plus cx dot is equal to k, right? Then open bracket, right? So now we're going to substitute in where there is a y, right? Where there is a y, we're going to put in what is given in the question. So what is given in the question is a, right? So if I can make this a square bracket, a sine 60t minus b sine 30t. Okay, then plus c, right? Then square bracket. Now we need to find the derivative for y dot. So you would have seen, if you do the derivation, you would have seen that the derivative was going to be equal to a value of, if I can just write it in general here, it's going to be a 60, right, cos 60, right, the derivative of yt, cos 60 t, okay, then plus b multiplied by 30, and in this case it's also going to be cos, right, cos of 30t, cos of 30t. Okay, so that is the derivative that we're going to substitute in here, right? So I'm just going to say that should come in this bracket since I am running out of space. So that is going to come into this bracket, right? So such that at the end of the day, what you are going to have is this particular expression. This particular expression is the one that you're going to have, right? So this boxed expression is the one that you're going to have, right? But what we do know from theory is we can actually further clean it up. So mx double dot plus kx plus cx dot, right? What we can further do is we can further clean it up by grouping these terms to write it in this particular format here. So if I can use my pen, which is particularly, we can simplify that to that. Okay, so we are also going to do likewise for this particular expression. So you're going to see that after having simplified it, it's going to be equal to c sine, okay, c sine of 60t minus phi, which is the angle, which is the angular, the phase angle, okay, plus d, a new algebraic expression, plus d sine. Remember, we have 60t and 30t, so we have to do for both of those angles. Okay, so we have 30t minus phi, okay, which I'll call phi 2. Okay, so ideally this would have been our solution, right? This would have been our solution. But now what the question asks us is to just derive the equation of motion, right, for the particular solution, right, and then explain in words how you would have solved it. Okay. Well, having solved this, how would have gone to solve it? Just an explanation in words as requested by the question. How you would have solved it is by using, right, use the principle, okay, use the principle of superposition. Yes, superposition. So we're going to use the principle of superposition to solve this particular OD, the particular equation of motion. And how are we going to do that? Well, we're going to solve it by superposition. That means that we are going to break it down into two parts and solve it using those two parts. The first part is going to be the part of C sine 60, right? 60t minus phi, right? And the second part is going to be the part of mx double dot plus kx plus cx dot is equal to d sine 30t minus phi 2. So this is the explanation that you would have said for this particular part B, particularly with more emphasis on the words. So as you can see, color, right? If I can use a different color, what you're going to see is we have this part, right? So this part of the superposition that is going to be added plus this part also of the superposition. So these are the two superimposed solutions that we are going to add in order for us to solve our equation of motion. So that brings us to the end of this particular question. I hope you found value in it. Please please leave a like, as well as also if there's any questions pertaining to what I've just done, please feel free to drop a comment in the section and I'll gladly assist. Thank you so much. Cheers.